Okay, welcome to Counting Atoms tutorial. You should be on page 11. Please don't fast forward. Listen to this video and follow along with each step. It is very important to count atoms accurately, and that's what we're going to learn here right now. Number one reads, the symbol of the element, as on the periodic table, represents one atom of that element. So the example here is barium, and when you just see a capital and lowercase barium, that means there's one atom of barium. So Ba just equals barium itself, one atom of it. Pretty simple. On to number two. A subscript, as defined in our notes, is a number written at the lower right corner. And I wouldn't say behind, I would think more like after the symbol of the element. If there is more than one atom of that element, then a subscript is used to indicate the number of atoms. So in this particular example, we have chlorine and the subscript 2. That means pretty easily there are 2 chlorine atoms. So we're going to write that on the worksheet there, following kind of the process. Remember, barium did not have the subscript, chlorine did, and that's why you get 2 chlorines. Gets a little trickier here down below. A subscript outside the bracket, like this number 2, multiplies all the elements inside the brackets. So we have to pay attention to the parenthesis brackets and the subscript outside. So let's deal with the calcium later and deal with this number 2 outside the bracket. So if you look at oxygen inside the bracket, it already has a subscript of 4. So the 2 outside the bracket will multiply times the 4 because it's inside the bracket. And 2 times 4 gives us 8 oxygen atoms. Remember, the 2 multiplies times everything inside the bracket. The phosphorus is the letter P, and because there's only one phosphorus, 2 times that one phosphorus gives us 2 phosphorus atoms. So subscripts outside brackets distribute and multiply to everything inside the bracket. Calcium's easy because the subscript is 3, therefore it's 3 calcium atoms. So we would total those up. You could add them all up if you were asked to give me the total number of atoms. In that case, it would be 13. Moving on down that sheet, coefficients, as defined in your notes, are numbers written in front of any chemical symbol, and they indicate the number of atoms of the element or number of molecules. Number of molecules, we can also think of that as compounds. So you need to think of a compound as one item. So in this particular example, we have 3 carbons, 3C, the coefficient's 3, and that would make that 3 carbons. Now that's just a single element. But in the case of sodium sulfate, our coefficient is 2. That means we have 2 sodium sulfate molecules. So if we're going to figure out how many of each of those elements, I see we have a sodium, we have a sulfur, and we have an oxygen. Our coefficient distributes to each one of those elements. So 2 times sodium would be 2 sodium atoms. 2 times sulfur would be 2 sulfur atoms. And because oxygen is already 4, that would give us 8 oxygen atoms. And kind of re-looking at subscript, a subscript is a number written after an atom in a formula, as we talked about before. It indicates the number of atoms in the kind in the molecule. So down here we have hydrogen sulfide. The subscript of H is 2 because we have a 2 there, and the subscript of oxygen is obviously just a 4. Moving on, let's go to the next page here as we continue the process of counting atoms. This is further down the page. We want to count the molecules in water here. We have 2 water molecules. So the first thing we need to do is write a 2 here because that's how many molecules there are. That 2 leads us to put a 2 here. And then if we want to count the hydrogens and oxygens, remember your coefficient distributes to each element. So 2 times 4 would be 4 hydrogens, and 2 times 1 oxygen would be 2 oxygens. So your coefficient distributes to each element down the line. All right, molecules for sodium sulfate. There's 3, so we just write the 3. That's easy. Distribute the 3 down to your sodium. 2 times 3 would be 6. Your 3 distributes down to the sulfur. 3 times 1 is 3. And your 3 distributes down to the oxygen. 3 times 4 equals 12. I would like you to do this on your own right now. Press pause and complete that activity just as we did in these previous examples. Moving on in this assignment to the next page, you're still counting atoms. It's lined up here a little bit differently, where we're going to write the actual elements for each one. So for example, potassium, we just list it here as K. Carbon, we list it here, and oxygen. So you're going to list your elements, then we're going to count them, and then it's asking you to total them, which is pretty simple. So 2 potassiums, 1 carbon, 3 oxygens, and all that information comes right from here. And if we total that up, that gives us 6 total. So if you were going to do this on your own, the first thing we do is we write down that element, which is obviously barium. We write down that element here. If you use your periodic table, which would be phosphorus, and then we write that oxygen down here. Counting the atoms, we have 3 because we have a subscript, right? Now here's again is that subscript outside the bracket, which distributes to the phosphorus, so there's 2. And the 2 distributes to the 4 there. 2 times 4 is 8. That gives us the 13. One more together, and then you will work on the rest of this on your own. Sodium, chromium, and oxygen. Sodium, chromium, oxygen. So our sodium is 2 because it has a subscript of 2. Chromium, there's nothing. There's no coefficient, and there's no subscript for it, so it's a 1. And oxygen is simply a 4. And if we total those up, it should be a total of 7. So this video will end. It is your job now to go do everything else on this sheet. And if you need to rewatch the video, please do so. You should be an expert at counting atoms because it will be important for balancing chemical equations. Thank you for paying close attention.